Right, hello everybody. Welcome to the end of Unit 1 review video. I'm Miss B, if you don't have me as your geometry teacher. I'm using a different camera. This looks much nicer than the last video. Um, Again, tips for studying. Try this review on your own. Try and do everything out of your own brain, everything you can. Then, if you are stuck on some of them, um, try and do it with your notes, okay? Then, if you are still stuck, come back and watch this video, okay? Like adding those progressive supports, because on your test, it's just you and your brain. You don't get your notes. Okay, and I just realized I don't have tracing paper, so I'll be right back. All right, so here is our first question. Reflect quadrilateral ABCD across line F. Now, reflecting is a fancy math word for flip. Okay, think about what has to be true about reflections. When you look at your reflection in the mirror, if you are walking further away from the mirror, your reflection is also getting smaller, right? It would be really creepy if you were standing 20 feet away and your reflection was still this close in the mirror, okay? That'd be really creepy. So, first thing I'm going to do is I'm going to trace my image, or trace my pre-image before I do my transformation. I'm also going to label my points. Okay, so I can kind of, oops, this is not straight. So I can tell where my, the points of my image are going to be, so I can label it accurately. Now, I know I'm going to flip, I'm going to reflect, but like, whoa, I just reflected my paper and I got kind of lost. Okay, you can trace this line on your tracing paper. And then after you flip, you'll be able to line up that line. What I like to do is have a couple dots. They can be wherever you want, but put some dots on your line. That way, I can also put them on my tracing paper. Okay, now I'm guaranteeing that my shape is this distance away from those dots. And even after I flip my paper, I'm still that same distance away. And all I have to do is line up my dots, and I'm just going to use the pointy part of my compass to kind of press on each of those points. But you can also peel the corner back and mark it. There we go. There's my 4 points. Again, I'm going to use my tracing paper to figure out how to name these points. When you name the image is the after you've transformed. So when I name my points, this is going to be C prime. This is going to be B prime. This is where B ended up after it was transformed. This one will be D prime and A prime. Once you have them, I didn't use my straight edge on my tracing paper because that's just kind of my tracing paper. But be sure you use a straight edge for your final work. If you're in Miss Clyde's class, you recognize this straight edge. Were you guys excited when Miss Clyde got new straight edges? She said you were. Right? There's my reflection. And you can see that from D to this line was one triangle. From D prime to that line is also one triangle. Okay, it should be the same distance away from your line of reflection. Again, if you were standing 10 feet away from a mirror, but your reflection was this close, that doesn't make any sense. Okay? So here we are. We're critiquing someone else's work. Lynn tried to reflect this triangle across line T. I think there was a typo, triangle ABC, this should say. She knows something went wrong because, hey, these are not congruent triangles. What is one idea she probably understands about reflections? Well, it looks like, well, number one, this definitely ended up on the other side of the line, right? Like that's a good start. But to me, it looks like she understands the image has to be that same distance away, just like we were talking about. right? Your image has to be the same distance from your line of reflection as your pre-image. So what is one idea she probably understands? The image needs to be, don't talk about my handwriting, the same distance away from the line of reflection as the original figure. You can say as the original or as the pre-image. Okay, it looks to me like she understands that. Like she's got some circles to show she's trying to get some equal distances, right? But what is something that she does not understand? Where did she go wrong? Like, I think C and C prime look good. Maybe let's connect these together. Let's see what's going on. So C and C prime look like they could be okay. B and B prime also look similar. But what's going on with A and A prime? Okay, see how I'm breaking down each piece of this so I can look individually? I don't think the same distance is my only piece of information. What else has to be true about this line connecting A to A prime? Okay, it looks to me like these are not the same distance to the line of reflection. So let's say that every point must be the same distance to the line of reflection as its image. Okay, looks like she's failing with A prime. So if this line, if these 2 points have to be an equal distance from this line, think about things we've done in this class that cut lines in half. Okay, maybe you said bisect or midpoint. What is the other detail there? Not just any bisector, but a perpendicular bisector. The line of reflection is the perpendicular bisector of corresponding points. Double underline. Okay, again, corresponding points, that just means like the before and the after. Okay, so like C and C prime would be corresponding points. Let's kind of test this idea with this image up here. Okay, if I have A to A prime, in theory, if this was truly a reflection, this line F should be a perpendicular bisector. So, pardon me 1 second. I'm not the strongest with my compass. You can see, hey, Mr. Dunlap, do you want to be in my math video? Wait, come here. We have a special guest. No, I'm filming a video for all the geometry students. Come here.
Hello, everyone.
Good luck
Oh,
on
it
your
looks
test.
easy. Yes, good luck on your test. You'll do well, trust me.
Thank you, Mr. Dunlap. All right. You can see that, hey, that is a perpendicular bisector. If I extended it a little bit, it would definitely be on that line. Okay. Any corresponding points of a reflection That line of reflection must be the perpendicular bisector. Otherwise, it's not really a reflection. If you guys don't know Mr. Dunlap, he's awesome. Tell him that Miss B said hi if you see him in the hall. Okay, Priya tried to translate. Okay, so we've done some reflections. Now let's talk about translating. Translate is just move. Move with no rotation, no reflection, just slide. Okay, Priya tried to translate triangle ABC by the directed line segment from D to E. But something went wrong because, again, these don't look like the same triangle. They do not look congruent. What is one idea it looks like she understands from a translation? Well, let's look at these markings. It looks like this directed line segment DE, that tells me both the length and the direction, okay? So, looks like every point was translated by 3.5. Okay, so translations move all points the same distance. But there's another detail when it comes to translations. It was on your check-in 3, the front. Two things are true about translations. I'm moving all the same distance, so there's some level of congruency here, right? But also, the other detail, because I'm literally just sliding and I'm not rotating at all, translations move lines along parallel lines. Anything moved by a translation will end up with parallel lines. So translations move lines along parallel lines. Okay, that means all of these directed line segments should be parallel, and also BC should be parallel to B prime C prime, which does not look true. Andre tried to rotate triangle ABC 45 degrees counterclockwise. Something went wrong. Oh, everyone's doing something wrong. The image doesn't seem to be congruent to the original figure. Okay, what is one thing he understands about rotations? So it looks like he's got, okay, so step 1, ABC 45 degrees. Okay, so there's my angle. Counterclockwise. Let's see. It looks like he's using a circle, right? Like circles, that's good. Like we should be rotating around a center. Wait, we should be rotating around a center. Did Andre say the center he's rotating around? I mean, 45 degrees counter, he didn't tell me the center. How can I rotate around something if I don't know the thing I'm rotating around? So he definitely understands that all 3 points were rotated the same angle. But look at this image. For A to A prime, he's using center D. For B to B prime, he's using center E. And from C to C prime, he's using center F. What the heck is going on, Andre? So something he does not understand, you need a singular center of rotation. He did not define the center of rotation. Okay, not only did he not define it, he changed it every time. What the heck? My students know that whenever we do rotations, I have you, let me see, can you see this? I have you place your pencil on the center so it stays still while you're rotating. Okay, so if he was translating ABC, maybe let's say he wanted to do this one, I would hold my pencil on center D while I rotate. See that? Whatever your center is, if you hold your pencil there, that center will stay still. All right. What happens to the diagonal of a rectangle when the rectangle is reflected across a line of symmetry? What does this suggest about the diagonals of rectangles? Okay, let's make a sketch of a rectangle. It might not be perfect, but let's make a sketch of a rectangle. I know rectangle has 90 degrees in each corner and two sides that are longer and two sides that are shorter, okay? Not perfect, but there's my rectangle. Okay, the diagonals of rectangles are like so. Diagonals. Okay, where are my reflective lines of symmetry? Where could I reflect over a line and my rectangle ends exactly where it started? I would say right down the middle here, right? If I flipped this over, I would end exactly where I started. And then I think here, same thing. If I flipped over that line, I would end exactly where I started. So then what does that tell me about the diagonals? Okay, let's see here. Again, let me get my rough sketch. Oh, this didn't turn out too good. Okay, if I reflect over that line of symmetry, so I'm going to flip this, and I want to line that up. Wait, my diagonals ended in the same spot. Okay, well, let me check this one. Wait, my diagonals ended in the same spot. Okay, so if there is a rigid transformation, a translation, rotation, or reflection that allows me to line up with the exact same shape, that has to mean they're congruent or they must be the same length. Okay, so let's see here. What happened? This reflection takes one diagonal to the other, which means they line up. So they must be the same length. I'm going to use that word congruent. All right. A quadrilateral, that's a four-sided shape, has both reflection and rotation symmetry. What type of quadrilateral could this be? Okay, so our quadrilaterals, we have a rhombus, a parallelogram, a rectangle, and a square. Okay, rhombus has all equal sides. All equal sides. Rectangles have all equal angles, all 90-degree angles specifically. Square is a special rectangle that has 90-degree angles and equal sides. Parallelogram just means each pair of sides are parallel. Doesn't say anything about the length. Okay. So here is our solution. I'm not going to draw some fancy ones, but a rhombus is one that has reflectional symmetry across diagonals. And rotational 180 degrees. Okay, a rectangle, we just talked about that one. A rectangle, which includes a square, squares are rectangles, has reflectional across the midpoints, that segment connecting midpoints on opposite sides. Over the segment connecting midpoints of opposite sides. Okay, this one also has 180-degree rotational symmetry. Kind of hard without pictures, huh? But I'm sure if you found a rhombus somewhere and tested it, it would work. All right. Find a sequence of rigid motions to take each vertex of triangle ABC to the corresponding vertex of triangle A prime, B prime, C prime. All right, so let's find a sequence of rigid motions. That means translate, rotate, reflect. In that order, you are going to describe. So trace on your tracing paper. Okay. Ideally, you're using a straight edge here, but I'm not. Okay, so first thing is translate. This shape looks kind of far away from this one. Okay. Translations need a direction and a distance. Well, I can't really describe a direction because I don't have a grid. I don't really have a distance because I don't have a ruler. I only have a straight edge. Only there was some way I could do distance and direction all at once. Oh my gosh, a directed line segment. Sometimes called a vector. I think in my class we've always been saying directed line segment. Okay. Pick a point. I think I'm going to do from B to B prime. Okay. If I move along that line, B to B prime, I can describe that as a translation. So let's say that. Translate ABC along directed segment B, B prime. That's my first step. Okay, now that I'm here, I don't know if rotating is really going to help me. Like, I could try and pick a center of rotation, but it's not really helping. It looks like I'm going to have to reflect. Looks like I'm going to have to reflect. And actually, I might mark these points while I'm here. Just so my teacher can see the hard work I did. Right? I need to reflect this. Reflection doesn't need a distance or a direction. It does need a line of reflection. Okay, so I need to reflect this over A prime, B prime. So I'm reflecting that image because now that I moved it, now I have an image and after. So reflect the image of ABC over A prime, B prime. right, Kiki and sorry, Kiki and Aditya are trying to stump each other by describing rotations and reflections. This is what me and my math teacher friends do all the time. For the 8 evenly spaced points on circle I, identify the image of each point after the given rotation. Okay, so let's see here. My tracing paper is getting a little messy, but that's okay. So point A, after a 180-degree rotation around center I. So I'm going to hold that, rotate 180 degrees. That is a straight line, 180 degrees is. So should be straight across from the center, which is point E. All right. This next one's a reflection, so let me draw my line of reflection. All right. Point F, okay, my tracing paper is a little messy. Point F after a reflection across line AE. Okay, so let me get those points so that I can organize myself just like I did in that very first one on the front, right? I did open circles, so I can tell the difference compared to all my other circles. Okay, so point F, and I'm reflecting over AE. So let me line up those open circles. Looks like I'm at point D. Point D. All right. Point B after a 45-degree counterclockwise rotation around I. Okay, well, this would be 90 degrees, right? Cutting 180 in half. So this must be 45. Okay, so if I'm here at point B, I'm going 45 degrees counterclockwise around I. That's going to be point C. All right. Elena, this is on the screen, wants us to prove that the measures of the 3 angles in a triangle always sum to 180 degrees. So she's using rigid motions, just like we did in class, to rotate triangle, I should say triangle ABC, 180 degrees around 2 midpoints. So let's explain how she labeled her diagram. All right. So, angle, like where did these come from? She rotated ABC 180 degrees around the midpoint of AB. Okay, so rotated ABC 180 degrees around, you need a center for rotation, right? Around the midpoint of AB. Once we do that, we can see that angle DAB is the same as angle ABC. So angle DAB congruent to angle ABC. Okay, that helped me get here. Then, you could also do a second rotation, or you can compare alternate interior angles, right? So you could say here, or my alternate interior angles are congruent. Okay, I also know EAC is congruent to angle ACB to alternate interior angles. Okay. Alternate interior angles happen when there are two parallel lines. So here and here, those two lines are parallel, and they're cut by that transversal, right? So if I'm inside those two parallel lines, but on alternate sides, I know they're congruent. We showed that with some rigid transformations, right? If I am here with angle C, I can translate down, and then that's congruent through a vertical angle. So we can always say that those alternate interior angles are congruent. So A, B, and C form a straight line. Am I on the camera? So adding them all up should be 180. All right, last page. Give the most convincing explanation you can for why A is equal to C. Don't just say because Miss B said so, because Miss Holstein said so. Mr. Geiger told me so, or Miss Clyde. Okay, most convincing explanation. We know we can prove that things are congruent through rigid transformations, right? That's what we've been doing this whole unit. So if I were to take this, okay, so y A equals C. So let me start with angle A. There I am. Hold on that center point. If I rotate 180 degrees, I end up at angle C. And I know it's 180 because, watch this, this point is going to end on the same line. There you go. Rotating 180 degrees. If you rotate 180 degrees around the intersection point of the two lines, A will coincide with C. Okay, you don't have to use that word necessarily. You can say A will line up with C. A will map to C. A matches C. Something along those lines. All right. In each part, lines AI and GJ. Oh my God. Does anyone else feel like G and J are the same letter? I have two friends, their names are Gina and Julia, and in my brain, that's like the same name. Am I just crazy? Okay. Angles EBI and BCJ are corresponding angles. Okay, so these are parallel. That's nice to know. Use a transformation that takes angle EBI to angle BCJ to prove they're congruent. Okay, so let's see here. Let's do these points. And the angle is talking about the angle measure itself, not necessarily the length of those line segments, okay? So, well, use a transformation. If I rotate, that doesn't really help. If I reflect, that doesn't really help. So I'm going to translate. I'm going to translate along this line until the image of B is C. And I can see, hey, that lines up perfectly. That lines up perfectly. So translation by directed line segment BC. That's where we went. We went from B to C. Oops. All right, now here's that phrase again, alternate interior angles. Angles ABC and BCJ are alternate interior angles. Use a transformation that takes angle ABC to angle BCJ to prove that alternate interior angles are congruent. Okay? This just says a transformation. We can do this a couple different ways. I'm going to show a couple, but I'm only going to write one, okay? So one thing that I can do is I can, again, translate this down to C and then rotate around C 180 degrees. Whoops. Okay, then it would line up. I could also rotate this 180 degrees around the midpoint of BC. What? Bet you didn't think of that. It would line up perfectly. So there's a couple different things. You could say, translate along segment BC, rotate 180 degrees around C. Okay. You could say translate along BC, and then BCJ must be congruent because vertical angles are congruent. Those are two different ways you can write that. I'm going to do the one that maybe you didn't think of. Rotate 180 degrees around. Let me label it if I'm going to talk about it. Point M, the midpoint of BC. Angle 1 and that 60-degree angle make a straight line. So angle 1 has to be 180, angle 1, minus 60, which is 120. Okay, and justify how you were able to find them. 60 degrees and angle 1 are, what's that word for two angles that make up a line? Supplementary. Okay, angle 2 is equal to 60 degrees. I forgot my degrees because they are corresponding angles. Or you can justify by translation, right? Like we did up here. Okay. So yeah. Angle 2, this must also be 45 degrees. You can use our justification of alternate interior angles. Or you can say corresponding angles and then vertical angles. This one must be 135 degrees because it's supplementary to angle 2. Okay, this is 180. Whoa, 180 minus 45. Supplementary with angle 2. All right. Hopefully that was helpful. Get some rest. Don't stay up too late. Hopefully you're not watching this too late on Monday night before your test. If you have any questions, ask your teacher. Use that time wisely in class. Okay, I know you'll be working on your projects on Monday, but use your time wisely. Thanks, everyone. Hey, subscribe. I want more subscribers than Mr. Cunningham. I have 29 right now and he's got 41. So you guys need to get me to more subscribers than Mr. Cunningham, please. Also, if you subscribe, you don't have to wait for your teacher to post a link to my video because you'll just know. Bye, you guys. Good luck on your test.